Thanks, Heather. I'd like to start out by first welcoming everybody. Thank you from wherever in the world you're joining us. Good morning, good afternoon, good evening. As Heather said, my name is Jeff Bonkoski. I'm an area manager in basically the Northwest. And I've been with Hazard Control Technology since about 2012. I retired from the fire service and started doing consulting work with the ethanol industry, which dealt with a lot of possible three-dimensional fire situations, and in working and training with them and doing the consulting work, I started to realize that, foams weren't the solution, and being the 21st century, started looking for a solution, which then led me to Hazard Control Technologies. And I hope to share some of the things that I've learned over the years about the encapsulator technology and dealing with three-dimensional fires with you today. So as we said, today's presentation is going to be dealing with three-dimensional fire solutions and maybe even some solutions before we end up dealing with a fire, how we can possibly mitigate and prevent them from even happening. When we look at our mission as a company, Hazard Control Technologies, we're trying to make the world a safer place. And we say, our mission is to encapsulate the world. We want to be a leader in fire prevention and protection, utilizing fluorine-free, innovative encapsulator technology. And what I always refer to a 21st century solution to 21st century fires. So as we go on, HCT is a global company. We have a distribution network that covers the world. We're based out of Fayetteville, Georgia, and we've been around since 1997. So this isn't a product that was just recently developed to offer a solution for fluorine. This has been a product that has been around and has been available for many, many years because of people trying to get rid of the forever chemicals, what's being more looked at, and the abilities of this agent to be utilized on some of these difficult fires is finally taking notice. So as we start out, we start looking at the three-dimensional fires, the risks, the hazards. Let's look at how we used to do it, and let's look at, today, how we can do it. When we talk about a three-dimensional fire, what is it? It's a liquid or it's a gas discharged either from an elevated, from a manifold, from a valve, some type of a pressure source, fuel running from a higher plane down to a lower plane. And if we look at the NFPA foam standard, which we used to use, it's been the only other thing other than water that the fire service has known, or even industry has known. And if we go into the NFPA standard, into Annex A11 of the appendix, and we look, we'll see that right in that standard, it states foam is not suitable for three-dimensional flowing fuel fires or gas fires. But what other options have we had up until now that we've been aware of? And again, with the push for non-fluorinated products, here we are. And I always kind of throw out to people, when we sit there and we look at some of these tests on the foam products and foams, we're testing them in ideal conditions indoors for use in outdoor and not so ideal conditions. So, let's look at how this new technology, the F500 encapsulator agent, is able to have a great effect on these three-dimensional hazards, and how, in the past when we've used foam, it's been ineffective, and why. Let's look at yesterday's technology when we test it and the problems that it's causing with those forever chemicals around the world, especially with military bases, with airports and other training facilities where we have been teaching and working to utilize techniques for foam applications on being able to fight the fires. When we sit there, we start looking at the foams and we talk about the three-dimensional fires. Here, you see the pail of foam, you see the firefighters applying, they're using, and we'll see here again, we end up with a slight, explosion. The fuel starts to spill out, starts running down the hill. Again, something that foam is not able to extinguish. We look at a normal everyday car fire. We look at Class D metals. We look at some of the issues. Again, with these types of things, foam, again, needs to be able to create a blanket to be able to smother. And when we have that three-dimensional aspect, we have to build up a rather tall blanket to be effective and being able to deal with these types of fires. When we sit there, we start looking at even some industrial, where we're using it in a structure. Again, gasolines, flammable liquids, gases, they have a tendency they're going to float on the water surface. So again, if you have that liquid flowing from a higher plane to a lower plane, even though we're applying foam, those flammable liquids burning are going to flow with the foam outside of the building. And yes, hey, here we've lost, $1 million apparatus because of the fact that the foam was not suitable to be able to deal with it. When we look at the techniques and the trainings and being able to put out these three-dimensional fires, and if you're dealing with ARF, crash fire rescue with airports, the petroleum industry, we know we need dual agents. You need the water, you need the foam to hopefully create a blanket and smother the pool fires that may be around the base. Water and foam, mostly water, to be able to hopefully cool the steel, the metal that's involved, and then using the dry powders to be able to smother out the fires. So again, I'm going to point out in this particular video, look at the number of hose streams that are being utilized to offer that cooling, as well as on the need for the dry powders. We look now at the F500 encapsulator agent, and we have a real quick video that shows you some of the effects and the abilities of the product for those three-dimensional fires. You see, it's one hand line, 95, 125 gallon per minute. Here we have like a well blow off type of a system. One hand line, 125 gallons per minute. We're not using 3-4 hand lines plus powders. It's one hand line with the encapsulator agent being able to do the cooling, being able to do the extinguishing. A mock-up of a jet engine colony, again, showing that three-dimensional, that difficult fire, that foam, and even with the powders can sometimes be difficult without the proper training. And here, in just a matter of seconds, with the encapsulator agent in the water stream, he's doing multiple things. He's encapsulating those vapors. He's cooling that steel. That steel is a source of reignition. And here we have, again, like a valve, a manifold, where maybe there's a bad seal or a bad valve and it catches on fire. Again, without the proper techniques with powders and foams, without the ability to have enough of the product on hand, you're going to lose tank farms, you're going to lose facilities. Where with the encapsulator agents, again, single hand line, being very, very effective at being able to cool, being able to control, and being able to extinguish these fires rather quickly. So the three-dimensional aspect is much different when we start putting an encapsulator agent into the water stream. And here's a valve, and many times when firefighters train, you have interposing hose lines trying to push the flames away from you. You're reaching inside between those hose lines. You're trying to shut the valve off to eliminate the gas or shut the gas down. And here, you're able to extinguish the flames and keep things cool while you're reaching in there to be able to extinguish or be able to shut off that gas valve. So those vapors now cannot find an ignition source. But while you continue to flow, even though the gas may be escaping from that valve and the fire is out, you're still encapsulating those gases. So with those foams that have been used in the past, we sit there and we have a map here that shows, this is showing here in the United States, all of the areas where we have basically contamination throughout the United States with all the PFOS and PFOS. now we're looking at the drinking water, and they're looking to try to reduce the amount of the PFAS in the drinking waters and trying to filter it out. So this is a huge, huge issue in not only the United States, but around the world. But, this is just a real quick interactive map that's able to show all of the different states and the contaminated areas, and just how much of an impact it has on us here in the United States. So as we go on and we look at more, we start looking at, a recent train incident that took place. Again, a three-dimensional fire. And it's showing approximately 75,000 gallons of hazardous wastewater that now has to be treated after that train derailment in East Palestine, Ohio. Again, the amount of water that's being used, and when we sit there and we look at it, as I continue on, we'll see how water is a very, very, I guess you could say, poor agent or a method to cool. It's when we look at the amount of heat that water could to reduce from testing that was done in some tunnel firefighting, where they were trying to see and measure the reduction in heat with water, it was like 6 million kilocalories of heat that were being able to be reduced when they were using the water to try to extinguish these tunnel fires, or these fires in tunnels. And when they started adding F500 into the water solution, it was like 21 million. So it was a huge increase in the amount of heat that was being able to absorb. And that even gets into when we start looking at trying to cool metal surfaces and all the other reignition sources that we have to deal with. When we look at, for instance, here in Maine Warrens, as far as the network of address to clean up the concerns after train derailments, diesel spills, and again, we have an article that's going to be part of the presentation. It's attached here that you can read. And while, yes, when we have these fires, it's a three-dimensional fire, we start using water. Again, let's look at how much was used in East Palestine. And while they're treating 75,000 gallons, how much more was able to get away before they were able to start containing and being able to control that water runoff. So, I mean, while it was 75,000 gallons, I'm sure that it was considerably more than that amount of water. And in many cases, you start getting out into some of these rural areas, well, maybe water supplies are a little bit more difficult to get out to these facilities. It now becomes an issue. The thing is we deal now after the fire is out with how do we do the cleanup? And when we sit there and we start talking about the encapsulator agents, hopefully I'll be able to offer some insight into that as well. And it starts here with an incident that happened in Chile, where there was a train derailment. This train derailment dealt with a couple of things. It dealt with the diesel fuel that was leaking. Well, luckily, there wasn't a fire, a diesel fire, but had there been, again, we're talking that three-dimensional fire. But in this particular incident, there was also the leaking of sulfuric acid. So the department in Chile that responded to this particular incident, using encapsulator agent F500, started treating the diesel fuel spill, because again, it is listed as a surface and soil washing agent with the US EPA, and they were utilizing it to be able to mitigate and help to reduce the chances of having a fire or explosion because of the heat that may have been yet within the engine, or a spark that might have occurred after the train derailment and while they were trying to do and separate the cars. But then there was also the issue of the sulfuric acid, the hazmat side of it. So the concerns were that they needed to be able to neutralize those acids as well. And we know when we start trying to neutralize an acid with a base, we have some type of a reaction. Well, when they started using the F500, they were able to neutralize that acid from a pH of 1 to a pH of 6 with no exothermic reaction, without having that cloud develop. which then led to another incident that involved trucks. A truck rear-ended a tanker that was carrying sulfuric acid, again causing a large spill. The spill was affecting the roadway as well as, an area off onto the ground. The environmental contractor that arrived on scene and the departments that arrived on scene, they started taking action, trying to neutralize this sulfuric acid, and downwind from this scene was a prison. With COVID, the government didn't want to have to evacuate the prison, and having been aware of the testing that was done with F500 at the train derailment and the effects that it had on the sulfuric acid, the hazmat side of that particular incident, they then utilized the F500 to neutralize the sulfuric acid. The top picture, if you look on that square up there, the top picture, that's showing the plume or the cloud that was being generated when they were trying to bury it with wet sand or wet dirt. The moisture was causing this huge plume to be generated. And when we sit there, we start looking to the picture on the right and the bottom, you'll see them using hose streams, utilizing F500 encapsulator agent, and there's no cloud, no plume being generated that affects downwind. We start looking at here we have another incident, which again, here could have been a three-dimensional fire. Unfortunately, when this tank truck rolled off the roadway, it was carrying 8,000 gallons of gasoline and a diesel, and it had to be uprighted and brought back up onto the roadway. The problem was, as they could not get the bottom valves to open so they could offload this tanker truck and reduce the weight. So what did they do? They opened up the dome covers. They rolled the tanker over onto its top. As you can see, the gas and the diesel is spilling out. F500 solution was being utilized to reduce the vapors, prevent any vapors or any fires or explosions from occurring in the event as in the process of rotating or turning that tank onto its top. There were no sparks generated that could have caused the fire. So the incident was mitigated safely, preventing that three-dimensional fire or preventing an incident that could have been a much larger impact on the community and on the fire department. So as you can see, they were then able to, once they got the tanker truck rolled over and reducing the weight, they also, in uprating the tank truck onto the roadway, used the F500 encapsulator agent. When we get into some testing that was done, this video comes to us from Vietnam. I kind of show this video because it gives us a real good indication of the abilities of the encapsulator agent and being able to control and being able to extinguish these fires. And the other thing is it shows how little we need to be able to extinguish this type of a fire. Instead of these thousands and thousands of gallons of water and other agents, the purple Ks, the powders and the foams and things like that, here we're going to utilize a nozzle that was developed there in Vietnam. It's probably putting out, I no more than maybe 60 gallons per minute. You'll see that the water droplets are very, very fine. It's a rotating tip that they've developed. The person, like I say, as far as the one leading the charge, you'll see here in the front, when he goes to pick up the nozzle, no gloves. The ability of the encapsulator agent to start absorbing the heat and to push back the heat is tremendous. So as he begins to make his attack, you'll see how fine of a curtain the mist is in front of him. He makes his attack. You'll see how rapidly it's able to have an effect at being able to extinguish the fire, start working on the three-dimensional aspects of this fire, cooling the steel, eliminating that reignition source. Okay, we have a 125 gallon per minute combination nozzle on the back, also with the 3% encapsulator agent in it. But you see how quickly it has an effect on being able to extinguish this three-dimensional fire. When we look at conventional methods to extinguish this fire, we wouldn't be able to extinguish it. Okay, we would have to wait for this fire to burn out because of the three-dimensional characteristics of the fire. Or we need dual agents. We need to be able to have an agent that can cover the pool fire and a second agent that can work on the three-dimensional aspects. When we look at, again, I mentioned previously about those spills on the ground, that diesel fuel, or other fuels that may get into the ground, onto the roadways and surfaces. F500 is on the EPA's National Contingency Plan and listed as a surface washing agent. The agent is fluorine free. It has been tested, and it is under the EPA 537.1 testing. It was tested for 25 different fluorinated ingredients, and the results were there's zero detectable limits of fluorine in our products. So when we sit there and start looking at it, and people are looking for that fluorine-free solution, here it is. F500 is biodegradable, it's non-corrosive, and as I said, listed as a surface washing agent. So let's get into and hopefully give you a better understanding of what an encapsulator agent is. As I mentioned, it's fluorine-free, it's non-corrosive, it's biodegradable. It's a multi-class extinguishing agent, CULS, NFPA compliant, as far as fire and suppression. And what I always point out in this particular, is combustible and flammable vapor and spill mitigation agent. And I always highlight that vapor because when I'm doing my trainings and I'm doing my presentations to firefighters and other organizations that are familiar with being able to extinguish fires, the question I often ask is, what do you as firefighters have to be able to control vapors and prevent a fire and explosion from occurring? And the question is asked because currently there aren't any that they're aware of. If they're using the conventional extinguishing methods, okay, the powders aren't going to control the vapors, the foams aren't going to control the vapors unless we're covering a pool and suppressing the vapors. But if it's a gas leak, it's going to really have no effect. But when we sit there and start looking at the encapsulator agent, we'll see how these agents are able to have an effect on the gases. When we talk about encapsulator agent, we need to have an understanding of how it works and a definition. When we look at the encapsulator agent and we start to get an understanding of it, we'll learn that the basic building block of the encapsulator agent is a spherical micelle. And the spherical micelles work on carbons, your alcohols, your petroleum products. And again, it works on that liquid and the vapor. And I like I said, I can't say enough because again, they're up to now, the fire service, and we have not had agents that can help us with that vapor side of things and being able to prevent those explosions and fires. So when we talk about foams, we talk about many of the other products that are out there currently being used. We're talking about agents that work on a mechanical basis, causing a separation, smothering, working again on a way to separate the fuel from the oxygen. When we start talking about encapsulator agent, we're talking about changing the chemical makeup of a water droplet, these spherical micelles. So we're working on a chemical molecular basis. And we'll see here with this video, which gives us a better understanding of how those spherical micelles are formed. So here is just a real quick animation showing again the basic building block. And it starts with our molecule, and our molecule has a polar head, which loves water, wants everything to do to be in water. And then that non-polar tail, which fears water, wants nothing to do to be in water. So when we sit there and we start to add it into the water stream, and it can be pre-mixed, it can be educted, injected, however we get this into the water, batch mixing, as soon as it gets into the water, those tails want to get out of the water, so it instantaneously orients into these spherical micelles. So now as these spherical micelles flow through the water and they come out of the nozzle or the sprinkler head, those spherical micelles closest to the surface, because it takes less energy for those tails to get out of the water than to try to stay in, stay in that micelle formation. The spherical micelles closest to the surface, they break apart, those tails spin out, and we now put a skin on the surface of each and every water droplet. And when we do that, we change the characteristics of how it's able to extinguish, how it's able to encapsulate those gases as well as the liquids. And when we look at the animation here, this final picture, we see that there's still micelles inside of each and every droplet. And just to give you a little bit of a visual, if that water droplet was the size of the Earth, those spherical micelles inside the water droplet would be about the size of a pea. So it just gives you a little bit of a visual as far as how many millions of micelles are yet inside of each and every water droplet, and what they do and how they work and how they're able to have an effect on. So let's look at now how the encapsulation side works. Being able to, once we've encapsulated a flammable liquid, we're going to reduce that risk of ignition or reignition and offer that burn back resistance. Again, mentioning about how some of the other agents are currently in the past being used, the foams working on that mechanical basis, they cause that separation between the fuel and the oxygen. The problem becomes that when that blanket breaks down, if we're not there to reapply and we still have that heat source present, once that blanket breaks down and exposes the fuel, we have a reignition. Or we have to be careful that if we walk through or anything happens that disturbs that blanket and exposes the fuel, again, we have that chance for a reignition. So working on that mechanical basis, when now we talk about the micelle formation and how the difference is between an encapsulator agent working on that chemical basis, what we're doing is we're encapsulating, we're trapping those fuels inside of those water droplets. Each and every one of those micelles, they're going to act almost like little Pac-Man, and they're going to hold those petroleum products, those carbons, those hydrocarbons, those polar solvents inside, those gases, those vapors, the hazardous gases that we hear about, being able to reduce the toxicity and the soot and smoke. Okay, it's all held within those droplet size. Now, the thing is when we sit there and we look at these spherical micelles and how they work, not only are they able to have the effect on being able to encapsulate those fuels and rendering them non-flammable, non-ignitable, we see here from this particular demonstration where what we're doing is, spreading some gasoline on the ground. We're going to use the encapsulator agent, and we're going to spray a line to basically separate, the two halves. And we're going to take a torch and we'll light up the other side. I'm showing that when we sit there and we've encapsulated the gasoline, it doesn't go across. We've encapsulated that gasoline. The area in the middle has been encapsulated. There's no longer a hazard. So we're now going to sit there and we're going to come back through. We are going to extinguish the fire completely, encapsulating all the rest of the gasoline that's still on the ground. Once we get this extinguished, we're going to walk back through. As you can see, it's not a foam blanket. There is a milky white discoloration to the water, but here we've encapsulated that gasoline. It's now within those spherical micelles, and we can walk through it. It's not a blanket. It's not something we have to worry about disturbing. That gasoline has been encapsulated. there's no blanket. Again, you see scraping my foot there on the surface, trying to show that there's nothing that you can disturb or nothing that's going to cause a reignition. The cleanup, as I said, this product F500 is on an EPA's national contingency plan as a surface washing agent. So on this particular instance, your cleanup is let it evaporate. Once it's evaporated, it's gone. It's no longer a hazard. When we look at that spherical micelle stability test, which is covered in NFPA 18A section 7.7, it basically talks about how the spherical micelle stability test is run, how it's able to encapsulate those flammable combustible liquids and rendering them non-flammable, not ignitable, non-explosive. I mean, we're going to sit there, and it's not something that's just going to occur for a matter of hours. Once that fuel has been encapsulated, it will not burn until it has evaporated away. And like I say, in doing some testing in pans and in other ways, I can say that when I put an encapsulated gas in a pan until it's evaporated, in a week or two, I have not been able to reignite that gasoline. So the question I asked here, and I hope, please, when we get towards the end of the presentation, take notes, or if you want, put your questions in the chat or be ready to share. But, here we ask, how is your team currently approaching three-dimensional fire hazards? What experience have you had with those types of fires? And, how have you dealt with them up into the past? And what difficulties have you had? How can we sit there and how can we address and help you in being able to mitigate these in the future? The next thing I want to talk about as we continue on is the heat reduction, because I've talked about the encapsulation abilities of the F500. And one of the other things we talked and I mentioned was that metal, that reignition source. And in the video that you saw from Vietnam with that tanker truck, I mentioned in there when they were spraying with those water droplets, that absorption of the heat, spraying that metal, being able to reduce those temperatures, dropping those down below that auto ignition temperature, eliminating that reignition source for the gas that's still flowing down the sides of the tank. So here we're going to talk a little bit about that heat reduction, and again, how the encapsulator agents in changing the chemical makeup of water droplets work. So when we look at water and using water for fighting fires, we're using it and it's in creating steam. We're converting water to steam to try to be able to help put fires out. And in many cases, we're using very, very little of a water droplet to be able to extinguish a fire. In many cases, when we're using water on a structure fire, on fires, we're using maybe 3 to 5% of a water droplet to be able to extinguish that fire. Now, when we sit there and we start looking at that steam, that scalding temperatures and so on and so forth, it's one of the hazards of firefighting. And why now we're sitting there and we're putting so much gear on to protect ourselves from the heat, from the steam, and now from all the toxins and the carcinogens that we're finding that are being released when we have these fires. And yes, a structure fire is a three-dimensional fire. Again, it gets into that category. We talk about the ability of the encapsulator agent to change that mechanism of cooling and extinguishing. Instead of it being steam, we use thermal conveyance. When we talk about thermal conveyance, remember the animation where we put those tails sticking out on the surface of the water drops, we put that skin on the surface. Those tails act like a heat sink, and they drive the heat inside of each and every water droplet. I mentioned those millions of spherical micelles yet inside of the water droplet. Those millions of spherical micelles, they rapidly absorb that heat, but then slowly release the heat into the water that's around them. And in that process, that water never reaches 212 degrees. It never creates steam. You'll watch videos where F500 has been used to extinguish fires, and you'll see a lot of heavy white mist coming off. It may appear to be steam, but if you were to take your glove off, or you take a bare hand and put it into that mist that's coming off there, it's been described as being no hotter than a shower. So it will not be a scalding steam, even though it may appear to be in videos. It is not. We look at the ability of the agent to rapidly drop those temperatures. This video is a good one. We got some thermal imaging taking place. This is a vehicle that was done at the Port Authority. It's a hybrid vehicle. So what they're doing is they're utilizing the F500 solution, and you can see just how quickly from the thermal imaging camera those temperatures drop. We'll back it up again here just a little bit. Here we see the fire, we see the flames. They start making that application, and just in a matter of seconds, the flames are gone and the heat is gone. Just that quickly. So your reignition source that we've talked about, why, even though there may be fuel in the area, the fire is able to be extinguished rapidly. Talk about the interruption of the free radical. Okay, how we're looking at that black smoke. In that black smoke, there is fuels that are basically still present. They just haven't burned completely, as well as the carcinogens and the toxins that are being released when we have these three-dimensional fires, and we have these fires. When we sit there, we start looking at this chain reaction. We start looking at the ability of the encapsulator agent to have an effect on encapsulating, again, those gases that are being released, how we're able to have an effect on the, for instance, lithium-ion batteries, the HF gas, greatly reducing the amount of HF gas. And again, when you watch videos on our website, and I encourage, please visit our website and look at our videos, you will see in many cases the black smoke that rapidly and quickly turns to white smoke. And the reason is because we're being able to have an effect on those carcinogens and those toxins where they form. Here's a good example. Here we're going to watch on this particular fire. We have the tires burning, black smoke at first. And again, you'll see just how quickly that black smoke turned white. And I'm going to back it up again so that you can see still a lot of fire, but where'd the black smoke go? Okay, it's gone. Now we sit there and we get into that white mist as I talked about. Okay, it is not steam. It's a warm white mist. We get into doing our overhaul, making sure that the fire's out, and we're able to continue on. In looking at the ability to reduce those carcinogens and the toxins in that black smoke, and again, we start looking at all the three-dimensional types of fires, those train derailments and others where we have large plumes of black smoke. When we sit there and we start utilizing this technology on working to extinguish these fires, and that black smoke decreases and turns white. From a Clemson report, the question was asked, what was taking place? So through some testing that was done at Clemson University using inverted glass funnels and using toluene as a fuel source, the testing showed that when they utilized F500 solution through the smoke column, that they were able to reduce the amount of soot by 97%. The toxicity of that smoke was reduced by 98.6%. And they were able to increase visibility because of the interference with that black smoke being formed. So it's a big thing when you sit there and start looking at structure fires again. So another question, what is your team doing currently to reduce your exposures to toxic gases and carcinogens? It's a huge issue in the fire service. I mean, these fires that we're being exposed to, these three-dimensional fires, again, structure fires, our truck fires and all industry, they're all giving off and emitting these toxic gases. And they're having an effect not only on the firefighters, but also possibly to our communities when those smoke plumes go downwind. So again, I asked the question, what are you doing to reduce your exposure or your community's exposure? So we sit there and we start looking at some testing that was done and some things that have taken place here recently. And, we start looking at, let's see about minimizing the use of water. Let's look at, how much we can reduce the smoke and the number of hours that firefighters are on scene at many of these fires. And this is some testing that was done by fire department in Quebec, Laval Fire Department, who were kind enough to share their results with us. This started because they had lost a brother in the fire service to cancer, and they wanted to hopefully find a solution to help with preventing others and making firefighting a safer profession. The same goals that I share as well as HCT. And they talk about here, above all, its use from day one could have prevented the inhalation of carcinogens fumes by personnel at a fire that they were on. So it's a huge thing that we're doing and trying to educate how, instead of being reactive and buying multiple sets of turnout gear, getting particulate hoods, buying wipes and all the other things, those, I mean, I'm not saying we shouldn't do it, but let's also take a proactive approach. Let's start utilizing encapsulator technology as we make our entry into these scenes. When we start fighting these fires, let's start knocking down those toxic vapors, those chemical clouds, those other things that we can have an effect on. Let's start reducing our exposure right from the beginning, rather than taking the reactive approach and trying to basically clean up after we've been exposed to these toxins. And these are just some pictures that came to us from the Laval. This is some drone footage that was shot when they were doing their testing. And what they had done is they had broken up this particular house and they were doing a series of fires. They actually did 4 fires. They did 2 fires using plain water, and they used 2 fires using the F500 solution. And after each evolution, after each fire, they started out with a fresh, clean hood. When they got done, and after each evolution, they would take their hoods off, they would put them into bags, seal the bags, given to a representative from the University of Ottawa so that they would be a chain of custody. And then they sent those hoods off to be tested. And as you can see, as we go through, let's speed this up here just a little bit. I mean, we get this fire to start burning a little bit, get that smoke. And one of the things that I like about this particular video is, again, when I do my trainings with departments and I talk to people about dealing with these fires, is a transitional attack. There's no reason why we need firefighters on the roof of a structure anymore. We're putting firefighters on the roof of structures for, well, a couple of things. One, they cut the holes in the roof for ventilation to get that black smoke and the heat out so that search and rescue can more easily find the victims. But when we sit there and we talk about the abilities of the encapsulator agent and that Clemson report, to be able to improve visibility, to be able to reduce the heats that the firefighters are feeling, we're able to use this transitional attack to actually start extinguishing the fire, cool those temperatures. And you can see here how quickly that smoke, as they make that interior attack, disappears. Okay, that white mist that's coming out, the improved visibility inside of the structure. And the same thing's going to happen if you are a firefighter, you respond to a structure fire. There's reports of victims inside of that structure. You use the transitional attack, you're improving your visibility, or you're reducing your heat, and you're making conditions much better for everybody that's involved. So when we sit there and we start looking at, the chemicals that and the reduction. This is a report comes to us from Laval, from the testing that was done from the University of Ottawa. It's a graph that's showing us the abilities of the encapsulator agents to excuse me, sorry about that. Hit the wrong button. I want to enlarge this a little bit, but we'll see here when they started using or started doing their extinguishing with plain water, and then with the F500, how much of a reduction. Here, we're looking at naphthalene, 71% reduction, 83% reduction on the and naphthalene. But all of these different chemicals, the great reduction in our exposure as firefighters, and it's not just structure fires, but again, we start getting into the industrial side with some of the fires that we're faced with, those train derailments, that sulfuric acid, where I talked about being able to reduce that pH from a 1 to a 6. Without having the exothermic reaction, without having the cloud form, again, reducing our exposure to these toxins. So there's many things in many ways that we can have an effect on being able to reduce our exposure when we deal with these types of fires. So when we looked at the conclusion from this report, and should be linked in with this presentation, the whole part is they at Laval are looking for an agent that would hopefully reduce firefighters' exposure to carcinogens, their exposure to toxins, and in moving forward, the 30 firefighters that were involved with this all agreed that the Laval Fire Department should move on and utilize F500 on all fires. When we look at it, the big push right now is trying to find products that are eco-friendly, that are fluorine-free, that are biodegradable, don't create or don't have that PFOS and the PFOAs, as we saw from the interactive maps, being able to reduce because of the effect that's having in groundwater in so many areas. And, we can sit there and we go back and we can start looking at reports from around air bases where there's cattle farms that have to eliminate or dairy farms that have to destroy the milk because of the cows drinking contaminated water. Areas in other states where there's a radius around an air base where don't eat the deer or the fish. So fluorinated ingredients are a huge issue in trying to eliminate those. And as I said earlier, F500 has been tested by a EPA approved lab. It was tested for 25 different fluorinated ingredients, including the PFOS and the PFOAs, and they're non-detectable. And that's been from day one. It's not something that, when F500 was first introduced into the market in 1997, there was fluorinated ingredients, and then it was removed. No, from day one, when the first batch of F500 was formulated, there has never been any fluorinated ingredients. So regardless of any misinformation that may be out there, if any of them may have, chances are it's due to cross-contamination, because we know, and when we start hearing about departments, and even with the crash fire rescue vehicles or any vehicle that has previously had, when we previously had the fluorinated ingredients in it, the current foams, when we sit there and we turn around and we try to flush those out, we can flush multiple times. And after flushing multiple times, we can go back and we still have detectable limits of a fluorinated or the PFAS still within the water when it gets tested. So that PFAS, once it's got into a system, it's hard to eliminate or get rid of it. So we look at states many states in trying to eliminate the fluorinated foams and working on basically making things safer, not only for the firefighters, but for the community, the environment. We're sitting there, we're looking at getting rid of the current foams that are being used. In Arizona, the firefighters were giving a choice, and they elected that when Arizona started into a buyback program to get rid of the Class B foams, what they did is they firefighters were surveyed, and they all came to the agreement that they wanted the fluorinated foams to be replaced with F500. So currently there's a program going on in Arizona where they're buying back these foams, and they're sitting there and they're replacing it with the free foam. And when we sit there, we start looking at let me go back here. The article, it's talks about here again, this will be included, but here we have information that shows the Arizona buyback, what it talks about, and how, again, with the Laval report, and then the on-scene decontamination and some other information in this report. So the Arizona firefighters, because of all this information, they did decide that F500 was the better agent for them to use, the safest agent, and basically an all hazards fire extinguishing agent solution. When we, as I mentioned earlier, talk about water being a very poor at reducing heat, because very little of it is used to cool, again, 3 to 5%. When we're trying to create steam, the surface tension reduction is poor. Look at foam. Again, the surface reduction is, like any agent, there is some surface tension reduction, but it's not much. We're working on that mechanical basis, causing that separation. And with heat reduction, it's very poor. Wetting agents are somewhat better, but when we get into the encapsulator agents, when we look at that NFPA 18A, we again now start talking about that spherical micelle, how it is able to work on that molecular basis, how we get that rapid heat reduction and that interruption of the basically the carcinogens and the soot and the toxins. So what we want to get into now is, and let's talk about planning, how do we do it safely, the multi-hazards classes, talk here about the lithium ion batteries. When we talk about the three-dimensional fires, while many may just look at it from the standpoint of it being a petroleum fire, that's not the case. Let's look at all the different areas where we can deal with, and as I mentioned, that structure fire is a three-dimensional fire. A recycling fire at a facility. It's not just a petroleum fire that's a three-dimensional. If it's got, as I said, any height to it, any motion to it, any spraying to it, it is a three-dimensional fire. And here again, when we look at, what's coming our way and growing rapidly is lithium ion batteries. In many cases, those lithium ion batteries, you look at those videos and you see those jetting flames shooting out when these batteries burn, you see the batteries, popping and flying off into the air. We're dealing again with that three-dimensional hazard when we're talking about these lithium ion batteries. When we look at the side-by-side video here dealing with legacy fire, how houses used to be built with their synthetic, or I should say with their natural fibers. We're dealing with woods, we're dealing with wools, we're dealing with our natural materials. We can see here how much of a difference it's made versus current everyday construction that we have currently with our synthetic materials. Okay, and while we see how the difference is, I know for those who are been in the fire service for a while, I know back in the day, early on, you could get off the truck with with the fire extinguisher, water fire extinguisher, and you could go in, and in many cases, you could sit there and have an effect on some of these fires. But today, with these synthetic materials, with these fabrics, with all the composite materials in our furnitures, these fires are growing so fast that when firefighters arrive, we're going into structures that are, more involved, rooms that are getting ready to flash or have already recently flashed. We're getting into temperatures that are much hotter than we used to. So heat and being able to protect ourselves has become a huge issue in the fire service. So we see this fire as it continues to grow, the three-dimensional aspects, just how quickly that room flashes, 4.5 minutes. Yet we look at the other room, how slowly it is as far as the progression of the fire and how it has an effect. So these three-dimensional aspects of the fire and how they're growing in today's construction and today's houses is a huge difference. So if we can now then use the encapsulator agent to have an effect on being able to reduce that heat, okay, reduce the carcinogens and the toxins that we're being exposed to, it makes a big difference in basically life safety, not only for the firefighters, but possibly victims that may still be within the structure that we're trying to protect and save. Lithium ion batteries, again, getting into those a little bit more in depth. Let's look at, for instance, the current thought process using copious amounts of water. The definition, can anybody give me a definition of a copious amounts of water? Is it 1,000 gallons? Is it 5,000 gallons? Is it 10,000 gallons of water? I mean, when I hear copious amounts of water and we start looking at some of these battery fires, I mean, a car fire, I'm hearing, 3,000 gallons, 30,000 gallons of water, a battery energy storage system, a sprinkler system flowing for like 10 days, over 2 million gallons of water. What's a copious amount of water? And in areas where they may be experiencing drought conditions, do they really have that much water? Yet when we sit there and start looking at, again, encapsulator agent, we go into the NFPA 18A Annex A 4.3, or if we look at the NEN NTA 8133 test that test extinguishers for the ability of them to be able to extinguish lithium ion battery fires, we'll see that encapsulator agents are very effective. And a lot of testing has been done showing that not only are they able to reduce the toxicity of the electrolytes, they're able to reduce the HF gas and the toxicity of the HF gas and the water runoff, but we need much less water. Much less water. I mean, when we were recently at NFPA, we had people, users of F500 that have had Tesla fires coming up and telling us that, somewhere between 350 and 500 gallons of water, and they were able to extinguish a fully involved Tesla. That is a huge difference between, the thousands and thousands of gallons we hear about of water being used for the same types of fire. We look at some testing that's been done with lithium ion batteries. This comes to us from testing what was done. This is one that I like to show because it has multiple visuals. We have some thermal imaging that's taking place. We actually get to see the batteries. We see a lot of wires coming off, and you'll look here on the bottom, and we've got some thermocouples, some thermal sensors. So we see as in that top left picture, we're going to start having some smoke develop on this battery. It's getting overcharged so that we can get into thermal runaway on a cell. We'll see that once that thermal runaway starts, it then leads to that thermal propagation where the cells that are, or batteries that are around that cell that initiates the fire continues to grow. And we'll then be able to watch those temperatures as the heat starts to build up and it starts to generate and go as it continues on and through its thermal runaway. The main thing that we'll see here, once we start to activate the suppression system on this, just how quickly those temperatures drop. And we're looking at temperatures that are over 600 degrees C, dropping down to 100 or so degrees in just a matter of seconds. So we see it gets in, that battery starts there, it goes off. We start getting into that thermal runaway and propagation. The fire grows. I'm going to speed this up just a little bit more. We'll see here with this number 5 and number 3, we're getting again 670 degrees, 600 degrees. The F500 solution is about ready to activate. You'll see here in just a second. There it goes. Our temperatures now went from over 600 degrees C down to 17 degrees C in just a matter of seconds. Now, with water, we often hear about once a battery's been extinguished, that you have a reignition. It's not uncommon to hear about reignition hours to days, and in some instances, we've heard even weeks later. When we've utilized the encapsulator agent, and this video does go on for some time yet, I believe that battery sat for 20 minutes, and the whole time that the battery sits there, the temperatures do not begin to rise up again. And all the testing that's been done using F500 encapsulator agent, where it's been used to extinguish the batteries, there's been no documented cases of reignition hours or days after it's been extinguished. So we look at the reasons and possibly the reasons why there are those fire and reignitions with water. Again, we look at that flammable and corrosive electrolyte. We talk about that stranded energy that's in those batteries. Once they've been extinguished, you've got that stranded energy. If there's an arc or there's a spark that occurs, you have a flammable electrolyte that's still there because water does nothing to neutralize it. So you do have a flammable source that is just looking for an arc or spark to reignite it. So good possibility that's what's occurring and why we're getting those reignitions hours to days later. We saw that ability of the encapsulator agent to encapsulate that gasoline. So we do the same with those electrolytes. We encapsulate, we reduce the toxicity and the corrosiveness of the electrolyte. We reduce the toxicity of that water runoff. We encapsulate, again, eliminating that fire hazard, that reignition hazard. And like I say, once it's been done, it's no longer going to be ignitable as far as being able to torch it. Now, that being said, if in the process of moving the battery, you damage another cell or you cause some more damage, you could have another incident that occurs. But as far as a reignition, there hasn't been any that we're aware of. We look at, again, the gases that are being released when we hear and we talk to people with regards to lithium-ion batteries. They talk about, the hydrogen gas or the methane, the acetylenes, and all the other things that might be coming off the batteries when they're burning and the gases that are being emitted. Testing shows that F500 can encapsulate that hydrogen gas, encapsulate that methane and the high ethylene. Those flammable gases, again, as I said earlier on, when I talk to firefighters and I talk to people about what do you currently have in your toolbox that works on flammable vapors, and you kind of get those blank stares. Well, here you now have a solution that you can have and be able to spray towards flammable vapors and encapsulate them and reduce those explosive atmospheres and reduce those explosion hazards. That toxicity, reducing that HF gas, and testing has shown that it greatly reduces in many cases down below, or it gives us about a 30-minute IDLH from testing that was done with some battery cells. that Johnson Controls had done and shared the reporting with us. Batteries that were putting off 2,656 parts per million of HF gas, and when F500 solution was used, the highest readings they got were 37. So it was about, you're about a 30-minute IDLH as far as your exposure limits. So it gives you a little bit of a safety margin as far as exposures. Not that you want to be in there, but again, the reduction in those gases, the exposure that you're getting to those gases can be greatly reduced when you start looking at the ability of using these agents, F500, in fighting your fires in today's fires. So now, other than water, does your team have an effective solution for lithium-ion battery fires? I mean, we look at and we see many of the reports, and they're saying the powders and the other things, and we understand they don't work. The solution is water, and it's copious amounts. And even though we're using water, how many times do we hear about those reignitions? But now when we start adding encapsulator agent F500 into our water stream, we can have a great effect, then requiring much, much less water to be able to extinguish these types of fires. So let's get into our delivery methods. How and what equipment do we need to be able to provide and get the F500 into the water stream? As I mentioned, the F500 can be batch mixed. It can be introduced in through eductors. However we get this into the water stream, we have the 2.5 gallon water extinguishers. We have the Kwamus, the quick attack mobile units, which come in various sizes at 25, 50, 75, and 100 liter. And again, we have our TKO nozzle, very effective for some of our smaller fires. We look at the emergency response trailers. We have working and trying to get with many departments and many communities are looking for trailers that they can use to be able to meet their needs and being able to supply F500 for larger incidents so that they can deal with them, especially when it comes to some of your industrial, some of our recycling, and some of our other applications where we need to have some better systems. And like I say, those trailers can be configured and made up in various ways to meet your needs. Here's one that is set up with the actual tank that holds 500 gallons. This one I know has been utilized on many occasions in the Kansas area, and I mean it's a very, very effective unit when it comes to being able to extinguish these fires. Some of the other for industrial, when we look at fixed systems, fire protection systems inside of buildings, or if you have master streams that you have pre-piped for the ability to provide solution for tank farms or other applications. We have our diamond doser, which can be utilized and installed into existing systems, your existing fire protection systems, your existing sprinkler systems. And then you have your water driven proportioners that are mobile, that can be utilized and be accessed on trucks. One of the nice things about the water driven proportioners is they work through a wide range of flow rates. For instance, it might work from 230 gallons up to 15, 16, 1800 gallons per minute of solution, giving you a more accurate percentage that you're looking for to be able to fight the types of fires. Where with inline eductors, you're getting to needing 200 psi. You have to match the eductor to the nozzle. There's some things that we have to take into account for. When you look at that, if the eductor's not right at the source, I said 200 psi, so we have to overcome friction loss and things like that. So they can be a little finicky, they can be a little complicated. And in many cases, when I've seen them in action, they have a tendency to fail. So the water driven proportioner is much more user friendly and a much better way to. With that, that then will conclude our presentation. I want to again thank everybody. Hopefully, this was informative and gave you some information on the differences and how encapsulator are able to deal with those three-dimensional aspects of fire versus, the conventional methods that we're currently using, the foams and the powders only being able to work on the two-dimensional aspects of the fire. So again, one of the things that I want to bring up is, when it comes to doing trainings, if your organization, your department would like to have some additional training, especially with lithium-ion batteries and cars and things like that, some of those areas where the fire service is seeking and looking for information, please, by all means, on the bottom at hct-world.com, visit our website, info@hct-world.com. You can use that as well. Contact us. We'll get you in touch with your area representative. We'll be more than happy to arrange for somebody to come out and do these trainings with you, get you the information, set up demos so you can see the product work, and get you some additional information that you're looking for. So with that, I want to thank you all for attending today. It's been my pleasure again to be able to present to you and give you the information. I wish you the rest of your day, evening, or night is a good one. God bless, and thank you all for attending. With that.